Welcome to Prajim Technologies. I'm Venkat. This is part 26, Properties. In this session, we will learn the need for properties. Consider the example that you can see on this slide. We have a student class with three public properties. Now, marking the class fields public and exposing them to the external world is bad because you will not have control on what gets assigned to these properties and what gets returned back from them. Okay, for example, on the right hand side you can see the problems with public fields, specific to this example. For example, the business rule states that student ID should be a non-negative number. Nobody should be able to assign a negative number, but since this is a public field, I am able to do that. So it's violating the business rule. Similarly, for example, the student name cannot be null, but this example, is setting that to null. Again, why is that happening? Because you exposed your class fields public. Okay, so let's look this in action. So I have the student class with ID, name, pass mark, all of them public properties. Fields. Now let's go ahead and create an instance of this class. Student, let's say C1 is equal to new student. And now our business rule states that the student ID shouldn't be set to negative number. But here, even if I set to a negative number, it is happily accepted. Similarly, name should not be not null, but here I am able to do that without any issues. And similarly, for example, nobody should be able to change pass mark because it is set to 35. Somebody should be able to only read this field. They shouldn't be able to change this value, but I can go ahead and change pass mark to 0. So anybody who gets 0 would also get passed. Okay, and let's go ahead and print this. For example, console.writeLine. What I want to do is I want to print maybe ID is equal to whatever is the ID, and maybe name is equal to whatever is the name, and similarly pass mark is equal to whatever is the pass mark. So let's substitute the values for that. So ID is in c1.id property, and similarly name is in c1.name, and pass mark is c1.passmark. So now if we go ahead and run this program, look at this. ID shouldn't be non-negative, but I'm able to set it to non-negative, and I'm able to print that. And name, I shouldn't allow an empty name to a student, but since these are public fields, I'm able to do that. And another thing, if you go back to the slide, if the student name is missing, then no name should be returned instead of an empty string. Look at this here. Name is set to null, which means nothing. So if there's nothing in the name, I should get in the output when I try to print it, no name instead of an empty string. And similarly, pass mark, nobody should be able to change that. It's a read-only field. I want to make it a read-only field, but since it's a public field, people are able to change it, to maybe -100 or 0 in our example, and then that 0 gets printed out. So all violations of the business rules are happening. So if you want to enforce these, then probably you want to turn your fields, your public fields, into private and have some sort of mechanism in place to control what gets into these fields and what gets out of these fields. Okay, so let's see how to do that. Actually, um, you know in the programming languages that doesn't have properties, they use getter and setter methods. This has been there from since the inception of object oriented programming. And remember that we have seen inheritance and polymorphism, which are two of the four pillars of object oriented programming. And you know encapsulation is yet another pillar of object oriented programming. So how do you achieve encapsulation? Um, to basically achieve encapsulation, in programming languages that doesn't support properties, using getter and setter methods. But whereas in C Sharp, in .NET programming language, in C Sharp and VB.NET, we can make use of properties. Okay, which we'll be looking at in a later session. But for now, let's see how we used to do it before properties. We used to have getter and setter methods. For example, let's say I don't want somebody to be setting the ID to be negative. So how do I do that? Now, first of all, you have to mark all these fields as private because we don't want to be exposing our fields directly to the external world. So let's convert them to private. And let's do the same thing with the rest of the fields. So private and private. And then since this is a private field, I want to follow a good naming convention as well. So I'm going to use an underscore. Similarly, underscore name and underscore pass mark. Okay, now since this is a private field, nobody will be able to access that outside of that class. So we will be talking about access modifiers in a later session. Okay, now, but then somebody should be able to set the ID value and they should be able to read the ID value. And to do that, we actually provide a method. So a public method basically to set it. So public void, let's say we call it set ID. And obviously they should pass an ID into this method as a parameter. So we can assign this parameter to this field. But then before assigning, we can inspect the value that is coming into this class. So if that ID parameter is less than or equal to 0, then we know that it's a non-allowed value. So what you can basically do is throw an exception. Again, we haven't seen exceptions yet. We will be looking at them in a later session, but exception is nothing but an error condition. We throw back an error to the user saying that any number less than 0 is not allowed. Okay, so throw new maybe exception, and we'll give a meaningful exception like student ID cannot be negative. Okay, otherwise if it's non-negative, if it is greater than 0, then probably we will set this class's ID field to the ID that's getting passed in. And so this just sets the value, but if they want to read that ID value, then we need to have a get method. So how do we do that? Public int, since we have to return the value back, so it needs to be an int, and get ID. So what will this do? This will simply return the ID value. So this dot ID. So now we know that if anybody sets a value to this field, it has to be set only using this method. And similarly, if anybody has to read this field, they have to do that using this method. So now we have control on what gets into this field and what gets out of this field. Okay, so in this case, let's say for example, we have only implemented the ID. We'll do it for the other fields in just a minute. But before that, let's see how to initialize that. So I have the student object, which is C1. And if I want to set the ID, now look at this. When I press dot, I don't see any of the fields there. I only see the set ID and get ID methods. So if I want to set the student ID, I can say set ID. And if I pass, let's say -101, let's go ahead and see what's going to happen. In the meantime, let's comment this line. Oops, just these two lines. Let's comment them and run this. Now we said that we shouldn't be able to set a negative number, but here we are setting the negative number. So what's going to happen? Set ID is going to get called. So if you right click on that set ID and say go to definition, which is nothing but this method. So as ID, what are we passing? -101. So 101 gets passed. Is -101 less than or equal to 0? This condition becomes true and it throws an error saying student ID cannot be negative. Okay, so we have control. So let's see if we get that exception. So if we go ahead and run that, and somebody is trying to set that to a negative number, so you see that there is an unhandled exception, student ID cannot be negative. So now the user is alerted. Whoever is making use of a class, they know that they cannot set a student ID to negative number. So on the other hand, if I set to a positive number, I go ahead and run that, I don't get any exception. But on the other hand, if I have to go ahead and print that, let's see how to do that. To get the value, console.writeLine, let's say student ID is equal to whatever. So how do we get the student ID? That is the student object. We have a get ID method. So what is this get ID method going to do? It is simply going to return the value that is stored in this private field. Okay, so now if we go ahead and run this, it returns student ID as 101. So these getter and setter methods, are protecting this field now. Okay. Similarly, we can make use of other getter and setter methods for the name. So let's see how to do that. Say for example, I want to set the name. So public void set name. And obviously, if we have to set the name, we have to pass in that name into this method. So if, okay, now this name should not be null and it should not be empty. Okay, somebody shouldn't be able to set my name as empty. So I need to check that. How do I do that? On the string class, there is a method called is null or empty. Okay, so this method will tell whether if it is null or empty. If the passed in name is null or empty, then what do we want to do? We want to throw an error. So throw a new exception stating name cannot be null or empty. Otherwise, if it has got something, then we want to set the name field of this class is equal to the name that we pass in. Okay. Similarly, if we want to return the name back, then we want to have a method get name. So the return type should be string. So public string get name. Now we need to do a check here. If the name is an empty one, if it is null or empty, I want to return no name instead of an empty string. So what do? If string dot is null or empty, and which is that one, this dot underscore name, then we want to return no name. Else what we want to do, we want to return the field itself, this dot underscore name. I hope this makes sense. Okay, because if you look at our requirement, if we go back to the slide, we said that if we go back to the previous slide, if student name is missing, if the object doesn't have the student name, and if somebody is trying to get the value of that field, then we should show no name instead of an empty string. So if somebody is getting the value of this underscore name field, they use this method. And if that field is null or empty, we want to return no name. Otherwise, if it is not null or empty, it means something is there in that field. We should return that in that case. Okay, and again, actually, you can use a ternary operator instead of this big if else. We have seen that in operators, video session. So instead of saying, if and the else, you can basically use this ternary operator. So return, what do we want to return? If string dot is null or empty, then I want to return no name, else this dot underscore name. So instead of all these lines, we can basically use the ternary operator. So if you're not sure how ternary operator works, please check my video on operators in this series. Okay, so now let's go ahead and test that. So if somebody is able to set the name to, let's say, set name, and they are passing in null. Okay, so let's see what's going to happen. Now I go ahead and run this. Look at this unhandled exception. Name cannot be null or empty. So they have to pass in name. On the other hand, let's say they don't set the name at all, but they are trying to print the name. So in that case, what should happen? It should, since the name field doesn't have anything in that, it should actually print no name. So get the name of the student. So if I go ahead and run this, so student name is equal to no name. Why? Because we haven't initialized the student name to anything yet. But on the other hand, if we set the student name to something, so set name to maybe um, Mark, and now if I go ahead and print this, the student name should be Mark. So now we have complete control on what gets into these fields and what gets returned from these fields. Similarly, I want to make this pass mark field a read-only field. Nobody should be able to change the value. If somebody wants to know what's the pass mark, they should only be able to get that. That's why I initialized that to 35, and I only will have now public int get pass mark. So what is this method going to do? It will simply return the value. So return this dot underscore pass mark. Okay, so now nobody will be able to change that value, but if somebody wants to know what's the pass mark, they will be able to do that using that get pass mark method. But look at this, there is no set mark. That's why they will not be able to change that. So in our class, we made this pass mark field read only by not having a get method. Okay, so obviously if I want to print a pass mark, student pass mark, then I simply c1 dot get pass mark, and we can go ahead and run that. So we get the pass mark as 35. So I hope this is clear. One thing to keep in mind, never ever expose your class fields, publicly. That's bad because we'll not have any control over what gets into these fields and what goes out to the external world from these fields. So if you want to have a better control and if you want to encapsulate those fields, then we make use of properties in C#. In programming languages that doesn't support properties, we use this getter and setter methods. So programming languages that does not have properties use getter and setter methods to encapsulate and protect fields. So in this example, we use the set ID, for example, to set the ID field and get ID to return the field, to encapsulate ID fields, ID class field. As a result, we have better control on what gets assigned and returned from the underscore ID field. And we know encapsulation is one of the 4 pillars of object-oriented programming. In the next session, we will actually see how C# make use of properties in order to achieve this encapsulation without having to use the getter and setter methods. All right, so on this slide, you can see some resources for ASP.NET and C# interview questions. So that's it for today. Thank you for listening. Have a great day.